teacher and take over your own classroom. So he'll be starting that in
So you want to
the
be a
spring.
teacher? No, because I wanted to be a teacher, but I changed to a lawyer.
Okay, fair enough. Yeah, lawyer. We're gonna have to eat in the middle of class. You get these back after class.
My client was not
Like,
He's hard too.
I'm start throwing chips away at this point. This is getting crazy. Yes, that is why he is here as a placement in college. No. Okay, so I haven't seen any questions about parent functions go up. Our agenda is parent functions. We're going to wrap up this set of lessons. I'm going to recap a couple of things for those who missed. And then finally, we're going to get into transformations, which this whole unit is about transforming parent functions. So we need to remember what those things are before we start. Now, I forgot last week, Mr. Anderson, we had talked about you doing the Hero Monday, and you want to rock that right now?
Yeah, I can do that.
All right, so Mr. Anderson's going to do our Hero Monday today. But afterwards, I will ask if there's anyone who wants to do it next Monday, and so be thinking about if you want to do Hero Monday.
Didn't we do this already? Or am I supposed to do this?
No, you should have turned that in last week.
Oh, we did this
Oh, that was
Oh,
on
no,
the last
no,
one.
sorry, that was leftovers from last week.
We started this one already.
Yeah, I'll take it. I'll give it to one of my football players. Well, all of these two, but yeah, sorry. Go ahead.
Okay, my Hero Monday is my grandfather. My grandpa was a super influential person to me. He grew up in a country called Malta, and he came to the United States when he was about 12 or 13. He used to, every week, me and my siblings, both our parents would work late, and my grandparents live right around the block from me, so my grandparents would always come over and just look over us at least once a week. They would always come over. My grandpa, he just taught me a lot. He was always a super kind person to me and my siblings, and always super patient. He taught me a lot of virtues like that, honesty, patience, stuff like that. That really helped me get to where I am today. And he was always super supportive of everything I did. He wasn't a huge sports fan, but ever since I started going to Alabama, he always watched all the football games, so that meant a lot to me. Same thing with hockey. I do commentary for hockey for our club team, and he hates hockey, or he hated hockey, but he always watched the games to hear me talk about them. So he really cared about me a lot, and he meant a lot to me. So when Walter said he wanted to hear me do a Hero Monday last week, I really wanted to talk about him because he really meant a lot to me. So
Awesome, thank you. Anybody want to share on Monday, next Monday?
Why we gotta do it every Monday?
It's called Hero Monday.
They were on Monday.
It's Hero Monday.
So if we do 2 people in a Monday, it's not gonna be here on Monday no more.
I mean, we could do 2 people, but there's only 20 people in class. I mean, if we get to the end and there's people who want to go who haven't gone, we can do more than one, but the reality is pulling teeth to get anyone to do a Hero Monday. So, anybody know that they want to share about a hero in their life next Monday? Okay, be thinking about it. I'd love to hear. All right.
I can do one?
Yeah.
I do my mom?
Did you already go?
No, I never do.
Okay.
I do my mom. I can see your picture?
Yeah, 100%.
Big.
So Monday would be the 6th, I believe.
yes.
Can you check that?
I'm gonna go after her.
Okay, so the week after that, we will actually be out of school, so it'll have to be 10/20.
But
Okay.
what we got?
Fall break.
So, yeah, fall break will be that week.
When is fall break?
The week in between 10/6 and 10/20.
So the second week.
Alright. It was, Brianna, it was you who said you wanted.
Yes.
Okay, sure.
Alright.
Alright, so let's go ahead and get started.
Let's get it.
Yes, sir.
If Veronica join our group, she by herself.
No, she can't join your group because you can't remember her name, but she can join the force.
What the force?
Okay.
Wait, I got a question. What day do they start?
What?
So, we will be on fall break during our homecoming week.
Correct.
Okay.
So y'all have fall break 10/13, 10/14, and then actually y'all will basically not be in school that much at all. Y'all, the 10/15, which will be that Wednesday, is the pre-ACT for sophomores and ACT work keys. for seniors, so it'll be a
So
e-learning day, so you're actually having an assignment, Finney, but you will not have to be in school. And then Thursday and Friday,
Okay.
which y'all will be happy to know those will be the first days that I miss all year, because I'll be at a conference.
Oh my, this is gonna be the best week of
You
our
will
lives.
still have stuff to do.
Nah, actually,
I wonder who I seen.
I already know your stuff's gonna be. but I
Is it
ain't
Miss
telling
Rice?
you. It is not Miss Rice. Miss Rice will be here for Miss Williams already. She already ensured that even before I could think about
Is
it.
it a guy, Miss Williams going with you?
Yeah, so myself, Miss Williams, and Dr. Mudd will all be at this conference.
I know Miss Wood.
Huh?
No.
Dr. Mudd is
I
too
asked who was Dr. Mud, why don't you say Miss Mud? Like,
Cause his name.
Cause
Wait, how you say
she's
Miss
a-
Rice?
she's
Not
not
like
like
Rice.
I know who gonna be in here, cause she always here when you're not here.
Is it a female?
I don't know her name.
Oh, she won't be here. She had to have surgery and
Is
so
it Miss
she's
Jameson?
not subbing anymore.
it better not be mentioned.
Alright, so parent functions, we gotta get back to here. So first off, we should have a prayer model out where we have taken notes and started working through some of these parent functions. And we're gonna continue with them. So Walter, you got
Tell me
your
how to
prayer
test
model
Friday.
out?
What you say this weekend was?
Say again,
I
Walter?
mean,
I lost mine Friday.
Dog, how did you already lose it? The plan is for test Friday. It may get pushed to Monday, but probably Friday.
yeah, cause you said this union was short.
This unit is very short. Mr. Anderson, do you see any extra copies of that prayer model up on that desk?
Yeah, there's a couple here.
Okay, perfect. Can you get one of those, Walter? Say again, sir.
I said I'm 2 feet.
You're what?
I'm 2 feet. I was trying to do Boreal.
Okay, so parent functions. What is a parent function?
A parent function are in the simplest form. There is not multiplication or addition.
Yep.
What defines the parent function is the main operation or no transformation.
So what was the defining operation for, say, a quadratic function?
Y
What
equals
my
X2.
x squared?
So what was the defining operation? So I'm not saying that's the correct equation.
Oh,
No, 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 listen to my question. That is the equation. So what operation defined that quadratic?
The square.
The square, exactly, right? So I want to make sure it's clear, like there is an operation here, but that square, what defines a quadratic is the only operation that is there. That's what makes it a parent function. Okay, so we're going to go over that in a second. What about the square root function? What was the main operation for a square root function?
Square.
I thought quadratic was a square.
No, wouldn't be the, I really don't know
What is it?
what.
Y equals root.
Cubic.
Yeah, Y equals root. What's it called? No, it's the word that you use. Is you say it's not just any. It's the word. It's not just any word, but it's. Mr. Kenny, it's a word that you use. It's. I ain't with the 2 lines. The 2 lines. It's another word for it.
No,
That's
not
actually
that
valid.
one, that's the algebra, Dad.
We're
No,
back
not
to it.
that. Not that. Like it's a word.
Hey.
I know, like, I know what it is.
Y'all making it harder than it has to be. What's the name of this function?
Square root.
Square root function. So what's the main operation? Oh, square root.
I said that.
You said a root, but which root? There's more than one root out there, square root. So we're going to talk about other roots a little bit today, but I want us to recognize, like, we should be aware that a square root function has a square root. That's what makes it a square root function, okay? That's what defined a lot of this. And so we got through, and so notice there's no addition, no subtraction, no multiplication, no negatives. It's just that main operation. Does anyone remember what I called the things that add, subtract, multiply? Like there's a term for it when it's no longer the parent function. And it's what we're going to go into next after this,
Transformation.
is the transformations, right? The parent function is defined by the main mathematical operation, has no transformations applied. Alright, so I'm going to skip linear, we did quadratic, we did cubic. Now, let's actually go back to the cubic really quickly. So, how did we, so we can always memorize the table. And it may look like I have this table memorized, but I don't. What am I quickly doing to get the inputs and the outputs and know what this cubic function looks like? Anyone remember?
No.
So it may look like I have all these points memorized, that I just spit out this table, but I didn't just spit out this table, it wasn't random. How did I figure out or remember what the graph and what the table looked like for this function? This is important for you to be successful in just a few minutes. I need you engaged.
Like you did -2 times, I mean square root 3.
Be careful, remember this is the cubic function. So what did I do?
You cubed it, what?
So 1, I didn't square it, I what?
You cubed it.
I cubed it, but what did I cube?
say square.
Yeah. What did I, it's like, right here, what did I cube?
-2. Well, like you squared the, input.
So I substituted, so don't forget that word, I substituted my input in, so that x is -2,
And get your output.
and I got my output. Because here's the thing, you saying that we cube it, that only works for a cubic function, right? But if I have a quadratic function, what am I going to do? What was the main operation for a quadratic? I'm going to square it, right? So, but at the same time, I can substitute my inputs in and get outputs out. Okay, so don't forget that. Use your function notation. That was one of the things y'all drove me the craziest on last week, because I literally explicitly said, hey, use your function notation. Write it out, show the inputs going in, the outputs coming out, because that's going to help you remember this. Like, I know that y'all probably look at it and like just think, oh, Mr. Kenny just memorized all those. No, I don't memorize jack when it comes to math, if at all possible. I understand what's happening. I substituted inputs in and got outputs out. Okay? So when we create our parent functions, we want to do that instead of trying to memorize everything. We're already looking at 7 different parent functions.
Here's again.
There's more than just these 7. Yes?
If you was on the ACT, if this was on the ACT test and you took it, how would you know to substitute the input to get the output out?
Well, so the parent function itself is not on the ACT, but transformations are, and so we're going to learn about those transformations. 1, 2, if it's a function, I'm thinking about inputs in and outputs out. Like, we need to remember what a function is mapping of inputs to outputs. So put some crap in. Like, that's it. Don't make it harder than that. We'll see some practice questions soon. We'll start doing ACT Wednesdays. But don't make it harder than that. Okay? All right. Square root function. I will point out and remind you, what was the input that I recommended that we kind of start with in the middle every time?
0.
And input of 0 is a great place to start, right? But that's in the middle. And then what did we do around that 0? Well, I mean, we had 0 in the middle, and then we did...
-1, -2.
Like, those are just good points to do. Like, could I cube a 5? Yeah, but 5 cubed is 125. I don't want to do that. Okay, but does anyone remember the problem that we ran into with the square root function?
Then we kept getting there. I don't know.
So, you're right. Somewhere we got decimals. By the way, you're going to probably want a calculator today. 1 person per group. Go grab calculators for your group.
Are you saying like, you said one problem we ran into, like that, last week when we had calculators?
When we use our calculators in that square root function, we type in square root of some of those numbers.
That's what I'm saying, are you talking about that?
Yeah.
Some people get decimals, or when they put it into square, they put the parentheses in the negative.
So that was when we were squaring. So that was a problem when squaring. Some of us typed this in and got -4 when we should have had a +4.
Then like
But we ran into some problems here with the square root function. Hey. Thank you. Go ahead and grab a C with the 9 since there's a space over there. Thank you. Okay. So, can someone type in the square root of -2? Oh man, I was not clear. I guess.
-2,
I
it
meant-
says non-real calculation. If you're doing a +2, it just be decimal.
Okay, so if you put in -2, square root of -2 is, it says non-real.
Say
If you took the square root of -1, what does it say?
Non-real.
Non-real. So we have to remember that the square root function is a little bit different than the rest. Can I take the square root of 0? Yes, square root of 0 is?
0.
0, okay? Can I take the square root of 1?
Yeah, 1.
Square root of 1 is 1. And then the square root of 2 is like a 1.414 or so.
Yeah.
And if you're like, man, Miss King, how do you know that? I've just dealt with square root of 2 for a long time. Square root of 2 is a really, really common number in geometry and trig and pre-cal, and calculus, all that stuff. But, so did we want to graph a 1.414?
No, we don't.
No, we don't. We don't want to deal with that fraction. Remember, we also did 3, and I think it was a 1.7 something, which we didn't want to do. But then we did the square root of 4, which gave us 2. Yeah, 2. Does anyone remember, and this was like the last thing, so I'm building back up to where we ended on Friday. The last thing that I showed you about a connection to the square root function that can help us know our inputs a little bit better to use.
Okay, it was the rise over one.
So,
No, it's x1, x2, it's
Nope.
y.
sorry, I hate to shut you down, but listen, when you say y2 minus y1 and divide by x2 minus x1, that's all about slope, right? Slope is only for what type of function? Yeah. We're not dealing with linear, are we? Does anyone remember what function the square root of x was really, really similar to? Or what it was connected to? All right. What was 0 squared?
0.
0?
Yeah.
No.
What was 1 squared?
1.
What was 2 squared?
4.
What was 3 squared?
9.
Does anyone recognize what points these share?
It's gonna be negative, but it's the same thing.
What?
Wait, what is that again?
No, what points these share?
Bro.
0 and 1. So 0, 0. 0, 0, right? 1, 1.
Then it says 4, 2, but then it says 2, 4.
But yeah, notice that 2, 4 became a 4, 2.
It's a
So
reciprocal.
that means it's gonna be
Not
9.
reciprocal, hold on. That's a good idea. What are you thinking, Rihanna?
It's
What are you
gonna
thinking?
be 9, 3.
So the next one would be a nice 9, 3. So, Finney, I'm glad you're bringing in language, but one thing to be aware of, the reciprocal is when we flip the fraction, because what a reciprocal does is when you multiply them, you get 1, okay? That's what a reciprocal does by definition. So it's not a reciprocal. There's actually a term for this that we're going to explore later this year when we study inverse functions, okay? So these are inverse functions of each other. It's called transposing. You don't have to know that word right now, but that's the term, okay? Okay, so notice 3, 9 became 9, 3. Because what is a square root? What does a square root ask?
For the fact. Well, yeah.
The question is, what was squared? Right? When I look at 9 and I look at the square root of 9, hey, what was squared to get 9?
3.
3.
And so what's the output? 3. So what would be the next set of points that would connect these?
10.
Say again?
10.
So like an output of 10 here?
Yeah.
What are we gonna square to get 10, do you know?
100.
No, 10 squared is 100,
5.
right?
You're
5,
gonna get 3
5
points,
squared?
3.6 something.
yeah, so first off, square root of 10, but 5 squared would be 5 times 5, which is 25. So now, I'll point this out. What's my next input? If I keep following this pattern, the input would be 4. And what is 4 squared? 16. So what's the next point over here? 16 and 4. I want to point out my inputs here go up by 1. Inputs
Oh, yeah.
going up by 1. What do these outputs go up by? Well, remember, we're ignoring these, right? The outputs here are going up by 1. They match over here. Okay? So, does anyone know, and this is where I'm going to wrap up to give you a good rule to go by for our square root function, because this is, again, everything else you can base very heavily on the middle of 0 and going from there. But what do we call these numbers? The 0, the 1, the 4, 9, 16. They're perfect something. They are inputs. These are called perfect. No, someone else says it. They're perfect squares. Because what are we doing? We're taking the square root. So what's the easiest to take the square root of? Perfect squares. So with a square root function, use inputs that are perfect squares. Can you use other things? Sure, but you might get decimals, you might get non-real calculations. So notice we get our perfect squares from the quadratic. So that's just a final little hint that I want to give you before we go to the next problem. We need to recognize this. If we're taking a square root, we need a perfect square. 2 squared is 4, so it's square root of 4. 3 squared is 9, so the square root of 9. And so again, if you make your quadratic, that can help you with the square root as well. So that's something to think about. So you can memorize it, or you can just say, hey, we want perfect squares. Now, I do just want to quickly point this out, and I want y'all to note these details. I didn't go up here because I can't here. If I square a -1, I still get 1. Well, can I take the square root of 1 and get a -1?
No.
Not if I just give you the square root of 1. Not if I just give you the square root of 1. We'll talk about when you kind of can, but it's not as a function. The last thing I'm going to point out is this, okay? Does anyone see the major problem if I did include these 2 points where these were transposed? Does anyone see the major problem? Because I see a major problem for this function. Look at that table, think about this function, what would be the problem? So I wouldn't write this down, I just want us to see this. What would be the problem if I included that -1, 1, that -2, 4, and flipped the inputs and outputs?
He's already a 4.
Say that one more time.
He's already a 4.
Why is it a problem that there's already a 4?
It's one input mapping to multiple.
That would be one input mapping to multiple outputs. Notice 1 and -1 as well, 1 and 1. So if I included these points, what would we no longer have?
A function.
We would no longer have a function. We're going to talk about this more later this year, but that's why we cannot use those points as well. That's why we cannot input those negatives. Although that's supposed to be a, oh, because that's supposed to be -1 and -4.
Yeah.
And it's coming from that issue over here.
No, they were supposed to be +1 and 4.
Well, it would be 1 and 4 from that. Yeah, that's
But
right.
it is still, yeah.
But we still wouldn't be able to take the square roots in those negatives for that reason. Okay. So that's why we don't have that negative side of things. Okay. So hopefully we understand that square root a little bit better. Again, what inputs do we want to use with a square root function?
Positive or perfect square.
We want perfect squares, right? Those positive perfect squares. All right. Now we're going to transition into a cube root function. Okay. I do want to point this out. Things are not random in mathematics. There are patterns. So the only hint I'm going to leave you with is this: a cube root, a square root function connected to what parent function? Square root connected to the square root connected to the squared, which was the quadratic, right? Square root and square. Any guesses what the cube root function might connect to? Huh? Maybe somehow connected to the cubic. I'm going to leave you with that hint. What I want you to do is I want you to develop a table and a graph for this cube root function. We're going to come back together in about 4 or 5 minutes once you've developed this. And yeah, so we don't actually have a grid up here. If you're a 4, no, Jack, you can use this grid. Okay, so you can erase this and use that grid. All right, let's get up to our vertical surfaces. Let's develop the table and the graph for our cube root function. Build our understanding of what is happening. A few times. I know it's easier just put crap in a calculator and get something out, but it builds good fundamentals that if you actually take the time to put inputs in and get outputs out, it'll help you. So f of 0 equals the cube root of 0. So my input of 0 has an output of 0. It's nice and easy. And then we go to f of 1. That's the cube root of 1, which is 1. 1 maps to 1. And then so Dalton started doing these other numbers. And I don't know how many of y'all took the time to do these inputs and see these outputs. I know, Walter, you did this, but you just did it on the calculator and didn't write it out. You did too. And notice, do you want to graph that?
No.
No. Do you want to graph that?
No.
Do you want to graph that?
No.
No, no, yes,
No.
no, yes.
And then we get to this one, 8, 8, 2. And so I want to make sure that this is clear, that we understand where this is coming from. Now, I've talked about it with a few groups. I know Mr. Anderson has talked about it with a few groups, but I want to remind you that I'm going to write this in purple so that you can see some of these big ideas quickly and clearly. So why in the world did we go from 1 all the way to 8 for my input?
Good. The rest of the other numbers was like decimals.
Yeah, but why did that happen? Why did we use the 8 so that we don't have to do all these numbers in the middle next time, so that we can know to go straight from 1 to 8? Why did it do that?
Because 3 times 3 times 3 is 8.
Close. Not, what's 3 times 3 times 3?
Perfect.
27.
No.
27.
It's not perfect.
So my next input.
I mean 2 times 2.
2 times 2 times 2 is
Yeah,
8. Okay,
That's
so
what I meant.
what is Rihanna referring to when she's
Like
talking
cube,
about,
like 8.
so cubes, right? Okay, so I'm gonna come back to this in a second. So I want us to understand, we don't want those decimals, but right here, okay? This is what I kind of talked about with one of the groups. I didn't finish, I only did this top point. But what I pointed out to this group is, hey, when we have a square root function, what inputs did we want?
Craig, right? Somebody did.
Well, what were the
Oh.
inputs? It was we did, okay. Let me,
I'm sorry.
no, you're good. Let me start at a different place, okay? We're trying to do the cube root of x. Okay? Cube root of x here. And so, what was the function that connected to that cube root? Cube, right? Okay. And so, when we substituted -2 in, and we did -2 cubed, we got -8. When we did -1 cubed, we got -1. 0 cubed, we got 0. 1 cubed, 1. 2 cubed, 8. So what are we going to call these numbers right here? If they're the result of cubing integers. Yes, but there's another term that I talked about with a few groups.
Perfect.
There we go. These, Jaden, are called perfect cubes because we're focused instead of talking. Hey guys, with a square root, we wanted our inputs to be perfect. What? With a square root, we want our inputs to be perfect
Cube.
for a square.
Oh, square.
Perfect squares.
Squares.
Square.
So for a cube root,
We want the inputs to be perfect square. I mean cube.
inputs to be perfect
Cube.
cubes. All right. So when we do this, right, this was my original cubic function. So first off, use your cubic function to understand the cube root function. Okay? So first, use your cubic function to understand the cube root function. And I love what Walter or one of the group members did here is they drew these arrows where -2, -8 became -8, -2. -1, -1 from the cube function became -1, -1. 2, 8 became 8, 2. Notice Rihanna earlier was talking about an input of 3. 3 times 3 times 3 is what? 27. That's my next perfect cube. So in the cube root function, it would become 27 mapping to 3. So we can understand our square root function through perfect squares. We can and should understand our cube root function through perfect cubes. Notice, with perfect cubes, can we have negative inputs?
Yeah.
Yes. So, negative inputs work for cube root. What do negative inputs not work for? Not square roots. Okay. Last thing. Actually, two last things. This is a nice graph right here, which they had the benefit of having a coordinate grid already made for them. You have to make your own. But notice all we did is 1, 1, 0, 0, -1, -1. Notice that perfectly matches the cubic function to start. But this is where it's different. The cubic function didn't look horizontal. The cubic function was more what? So which direction though? Because this is pretty stretched out.
Oh.
The cubic was vertical. The cube root looks more horizontal. Well, again, we'll talk about more why that's true later, but I need us to recognize this is not a cubic. We gotta keep in mind the difference between a cube root and a cubic. And it's that term I talked about earlier with an inputs and outputs transpose. But notice, and I think it was Annalise, you were talking earlier about like the graph and the table. And I really just want to emphasize, like, if we understand inputs in and outputs out, we don't have to memorize anything. And we can know the general shape of a cube root, and you should know the general shape of a cube root, but you should also be able to think through what inputs in to get the outputs out to have a precise graph, not just an approximation. So, next thing, please make sure it doesn't get horizontal. Just like with the cubic, it doesn't ever get perfectly vertical. This never gets perfectly horizontal. It's going to continue going up and to the right forever. It's going to continue going down and to the left for forever. Okay, so it's going to continue that piece. Last thing before we continue, and I need you to learn from this and take notes about this. Ooh, I forgot about this. Be careful. A group over here was talking about how we need actual numbers. Don't forget, decimals are actual numbers. I get the idea. Usually when we say actual numbers, what we mean are whole numbers. Which, remember, whole numbers are your numbers that don't have a decimal and are positive. If it's positive or negative, when we include the negatives, they're called integers. So if you weren't familiar with those terms, let me know and I can help. All right, right here, I need us to be careful about this. Right here. Can anyone point out what is wrong about this axis so that we can learn from it?
The way they got it, they just want 1, 8, and 27.
Yeah, can you just go, guys, by those inputs,
No.
that scale? Oh. And also, is that supposed to be my X or my Y here?
Your head.
Yeah, it's supposed to be my
Head.
X,
And they put a
right? They put it on the Y. So, guys, we gotta be careful. These are now my X values. They need to go on the X axis. The second thing, yes. Hey guys, you cannot just go by the numbers there. You have to have a scale that goes by 1s or 2s or something, right? If you want to, you can go by 2s. You can change the scale. That's perfectly fine. But notice I'm adding 2 every time. And this is not the only group. I saw a few of us making this mistake. We need to learn. I completely skipped 4 and 6. See, even I do that sometimes. So now, 0 maps to 0, 1 maps to, and I can go by 1s here. Notice, hey, I'm still talking. Do the x-axis and the y-axis have to go by the same scale?
No.
No. If you want to stay consistent, you totally can. But please notice I'm going by 2s on the x and 1s on the y. And then 8 maps to 2, right? And so I'm using my points on the table to make sure I graph this well. All right. But that is the general shape of a cube root function. I will point out a cube root looks like a whole lot like a cubic function, but horizontal more than vertical. All right, let's please get our table, our notes, our graph down through the cube root function. Come on, guys, we gotta get to the math soon. Quick.
No way.
Please let me or Mr. Anderson know if you have questions.
So bye.
No, you doing negative 2, my bad.
Thank you.
So what do you
I want you to say thank you to me.
Thank you, Brianna, just for you. All right, so I'm going to pause for a second. I'm going to have y'all pause. I do want to emphasize that I want to encourage y'all looking around the room. Y'all's graphs are so much better, okay? The way that you're scaling your axes, y'all doing a great job with that, labeling things. Now, I want to pause for a second. I need us to see something, okay? Hey, I need feet walking this way. I need eyes and ears over this way. So everybody walk this way so that you can focus. Hey, Coriana, y'all had the graph right originally. That is not what you want to do.
So, wait, he just told me something, so I changed it.
I ain't sure enough.
Yes, you did, bro.
And you listen to the wrong person.
You're on a top lazy.
Alright, I need y'all to walk this way. KB, walk this way. Coriana, Carly, this way. Ivan, this way. Walter, can you scoot to the side a little bit? Alright, hey guys, I need to emphasize, I need to point this out. I need y'all to hear me on this. At the end of the day, if you are lost, how do you get a function? the end of the day, if you're lost, how do you get a function?
Get found.
Multiply.
In this one, I'm just saying in general, how do you get a function? Do what with the equation?
I'll say.
There's two words that I'm looking for that no one has said yet. Jaden, walk this way. Carly, walk this way. Ja and Ivan, you can't see well. You're all the way over there. I didn't ask. Walk this way.
She stood in front of me.
Ivan,
Boy.
walk this way. Brianna, walk this way. The closer you are to the action, the easier it is to learn. The further you are from the action, the harder it is to learn. Get up and involved in the action. All right. I'm about to kick you out of that chair because we're using that as a lazy way to move around the room rather than being more on top of things. I'm about to say no one can sit in the chair. Is that clear?
Well, you gonna ruin for everybody.
All right. So, hey guys, what's a key term that I talked about with cube roots and square roots up there?
Perfect square,
Perfect squares, perfect cubes, but what were those? Those were our what? There's an I word you're missing.
Integers.
There's an I word you're missing. It's up on that board.
square root.
No, that's not an I word.
Input.
Those are what?
Input.
Hey guys, inputs.
Let's go.
Like, guys, if we're talking about a function, at the end of the day, inputs in and outputs out.
That one, I'm close.
But y'all are, some of us are not taking the time to through a few things. Now, I want to emphasize, I need y'all to hear me on this. I saw a group, and I'm not going to call them out at this point, who did this. Right here, okay? Hey, guys, we have studied exponential functions. One, how do we know this is an exponential function? How do we know this is exponential?
The X,
Not yet.
X is the variable.
The x is a, well, yeah, the x is always a variable. Where is that variable?
The X is the
In the
exponent.
exponent. The variable is in the exponent. That's how we know this is exponential, which means we are repeatedly multiplying. How did y'all manage to get further away?
Who's y'all?
I'm not looking at you, I'm looking at him, and then Jaden moved further too.
What you mean? I kind of got closer, actually.
Dog, when you're here, and then you move over there, that is further away. I don't know how you think that's closer.
All that matters
Jaden.
is that I'm focusing. So let's, speak to you.
Mr. Kenny, you haven't been teaching for almost as long as I've been alive. You have no clue how I learned. You're right. You are so right. Okay, so,
I am.
right here, I've been teaching for 13 years now. And you're right. That is 4 years away, but in the grand scheme of things, and I've been tutoring since I was in college, so really we're up to 17 years. All right. Right here though, 2 to the x. Constantly, repeatedly what? Multiplying by 2. Notice, 2 times 2 is 4, 4 times 2 is 8. Hey, what's 0 times 2?
Zero.
0. It's not that 2, is it?
0 times any number is 0.
Thank you. So, we have got to remember when we do 2 raised to the 0, that's not 0. What is it?
1.
It's 1. Because what's 1 times 2? 2. 2 times 2. 4 times 2. Now, I'm going to throw this back to something that I need us to firmly understand, that I actually showed y'all to teach you this the first time. We have always said that a positive exponent is repeated what? Multiplication. Positive exponents are repeated multiplication. But when I look at this, most of us would just say it's 2. But we're literally saying that a positive exponent is repeatedly multiplying. So what are we multiplying by?
2 times 2.
Remember how it was 1 times 1, 2. 2 to the second was 1 times 2 2's. Okay? So it's starting at a 1, which is why when I go all the way back to 2 to the 0, what is it? 1, and then how many 2's am I multiplying by? 0. I'm not multiplying by any 2's. Which is why, again, for those of y'all who are freaking out a little bit, but when I go to 2 to the negative 1, where am I again starting? I'm starting at a 1. But I'm not multiplying this time. What am I doing? Dividing by 1, 2. Yeah, 2, but 1, 2. So, huh? Good question. I'll show you in a second. But, I mean, your group already did it. Okay? So, we need to recognize, so these values are good to go. But we gotta remember, anything to the 0 power is 1.
Oh, one power.
Good.
Power.
No, anything to the 0 power.
Who's one?
Oh.
How did that fall out so easily, Josh? See, this is why I can't trust high school students to be off to the side, because we gotta try to be slick, and then things gonna happen. So we ain't sitting off to the side
That's a very
anymore.
crazy
We clear?
way to, okay, that's
I don't know, I think I see a phone in his pocket.
Job.
I ain't gonna lie, I can vouch.
Oh my God, number one.
Never require you to trust your word, and I don't. Alright, right here. Hey, bringing it back. We've got our inputs in, we got our outputs out, but we need to again understand exponential function. But don't skip any points. What is 0 map to? 1. What is 1 map to? 2 maps to? Now, for those who are like, well, Mr. Kinney, how do we graph that? Remember, that's 1/2. Isn't that literally in between 0 and 1? Halfway in between?
Yes.
Okay, then we got 1/4, which is going to be halfway in between 0 and a half. And then that's enough. But just remember, when you graph that exponential, I talked about with this group over here, what's this exponential going to have right here?
Horizontal line.
A horizontal
Asymptote.
asymptote.
So you can get this exponential.
Yes.
Ooh, that could be for a note right here.
But
For real, Walter?
that is actually a good note.
That's good enough.
So here's what we need to remember that I would add into this is, so once again, we got back to this idea. What's the good middle input to have? 0, right? So, a good middle input. No, what?
3 is a good number.
No. 0! We want 0 in the middle, dog. We're making that table. What do we want in the middle?
Oh, y'all put 0? I'll put 3.
Is your table right here? Okay, so first off, hey guys, listen. Except for the square root function, 0 is always a good value to have in the middle, and then you do a few positive and a few negative. Okay? Notice, I'm going by 1s in my input, but that we need to remember for these over here, what is a negative exponent? Repeated, not a negative exponent. What was a negative exponent? Guys, what's that fraction bar mean? Thank you. So negative exponent is repeated division. Thank you. Which is, yes, why we're going to get some fractions in there. Negative exponents are repeated division. Please get your notes about your exponential function. Make sure you have that horizontal asymptote. Inputs in to get outputs out. Think about which inputs to have.
Yes, you did, bro.
Okay then.
You did though.
On my life, I did.
I don't like it.
I just said laugh, that's all I
Okay,
said.
I don't care.
Ivan. Notes.
Evidence of student character.
Yes, Mr. Kennedy. Why do you say it?
About it
We-
is out of business.
We were laughing at that's what it comes down to. Alright. Last detail I want to point out, because I noticed something that Walter said made me think about this. So Walter made the note, and I didn't think much about this earlier, but he made the note of like, oh, we can get decimals now. I need to caution y'all, because you can always get decimals, you can always graph decimals, they're not always the most efficient. But remember, this graph, is it continuous or is it discrete?
It's continuous.
It's continuous. So are there decimals right here?
Yes.
Are there decimals right here?
Yeah.
And here? So there are decimals there, it's just easier to work with integers than it is with decimals. But with the exponential function, we really don't have that option. If we get negative inputs, we're gonna get some, some decimals on that negative side, right? Okay. Hopefully we should have our exponential down. Once again, I do want to point out, if you ever get lost, what can you always do to make a graph? There's 2 words.
Oh, never mind.
Inputs in to get,
Output
I'll
out.
put out.
you can do that in a different class or another time, thank you. Alright, so we've done exponential, now we're on to absolute value. Now, I want to clarify a couple of quick things before you start on this. The absolute value function should not take this long. It legitimately should not. And I'm going to explain a little bit about where it came from later, but I want to make sure this is clear first. what is the absolute value of 2?
Wouldn't it just be 2?
2? Is
The
that true?
absolute value.
Absolute value of 2 is 2? Okay. What's the absolute value of -3? Let's do -2.
Positive 2?
Also positive 2? Okay, what's the absolute value of 3 minus 2?
3 plus 2.
So 3 plus 2?
Ain't it basically the opposite? Well, not opposite.
Those are good ideas, okay? What do y'all think? Would it be 3 plus 2?
I said positive 1.
You would have said positive 1?
That's not it.
Why do you think it's positive 1?
I would have solved it out then. If it was like a negative, well, it's a negative, and then just change, I don't know.
Well, so 2 things I want us to be careful about with our language. You're not solving here. What does it mean to take a big expression and make it smaller or simpler? You're simplifying, okay? Solve specifically means maybe to find what makes this equation true. We'll talk about that more later. So solve is only a term that we use to find what makes the equation true, but we simplify. So Walter, and I'm glad you said that, because that's actually why I asked this question. I was wondering if anyone would think this. Please understand, this doesn't just make everything positive. What it does is, we'll talk about that in a second, but you need to simplify first. What is 3 minus 2? 1, and what's the absolute value of 1?
1.
Positive. The most common idea that students have with absolute value is it just makes everything what?
Positive.
Positive. Did you know that's not actually what an absolute value does though? Like that's the result, but that's not what an absolute value does.
What does it do?
About to get there.
How do you even get an absolute value on this calculator?
I'll show you after we talk about this for a second. Alright, what is the absolute value of 2? We already said it was what? 2. And we said the absolute value of -2 was what? 2, okay? How far is 2 from 0?
What? 2.
2. How far is -2 from 0?
I remember this.
Negative
2.
It is not -2.
Positive 2.
It's still 2 away. How far is -4 from 0?
4.
It is 4 away. This doesn't matter, and it's a simple thing when we are dealing with single integers like this, but what you're going to learn about is something called a complex number later. And so we need to understand an absolute value is not just a positive, an absolute value is the distance from the, I wouldn't. So yeah, so an absolute value is the distance from the origin. When it's a single value like 0, it's 0, right? But it is the distance from the origin, or 0 in this case. So an absolute value does not just make it positive magically. Have you ever called up your mom and been like, hey mom, I'm -5 miles from the house?
No.
No.
No, that'd be weird. It doesn't matter what direction you are, how far are you from the house?
5 now.
5 miles, right? So because it's a distance, it's positive. But what an absolute value is actually determining is the distance from the origin, or from 0 in this case. Okay? So that's what an absolute value actually is. And now we're going to use that absolute value function, and we're going to try to figure out what the graph of it looks like. So once you have your definition of absolute value down, go back to your vertical surface. Let's figure out the graph and the table for an absolute value function.
I don't know.
Just because you don't understand how bad this gets. Like, this is
Let's
crazy.
get up and let's work. You're right. I don't. I will gladly admit that. Hey guys, you don't have to be in the view of the camera, but because it's centered more on me, but I need y'all to walk this way, out of the seat. I know you got football right before this class.
He ain't did that today.
Okay. But I was really gonna say, you still need to be able to stand up, guys.
over here when?
Hey, I'm talking, baby. Listen, okay. Hey, I'm still talking. Guys, when you stand, your blood is having to flow more. When your blood flows more, it means there's more blood in your brain. You're actually able to think better. It's not random that I ask you to stand. When you stand, you are more engaged. Point blank period, okay?
Who are you, Mr. Grizzly?
Yeah, I have, you know, taken chances, gotten messy, and made some mistakes along the way. So I've learned something. How about you? So right here, I just want to point this out because I had this question come up, and I think this is a good question. So I was talking with a student who was asking, hey, does that mean that this becomes positive? And the idea was thinking we do the absolute value of 2 like this. Hey guys, it doesn't become positive until you take the absolute value. So don't write the absolute value of 2 like this, because it's the absolute value of negative 2. What is the absolute value of negative 2? 2. That's the same reason a lot of students make this mistake. When we do the square root of 4, what is the square root of 4? Hey guys, what's the square root of 4? It's 2. And then students will write the square root of 2. But it's not the square root of 2, it is just 2, because we took the square root, okay? Now, listen, I know a lot of us saw these graphs last year. We need precise graphs. And I also want y'all to actually understand where this came from. Mr. Anderson and I talked about this before class today. We knew this absolute value. We knew how to do inputs to outputs, right? But do you know where this graph actually comes from? Does that equation or that graph remind you of anything?
Exponential curve.
Exponential curve? Wait, what?
I don't see the curve.
I don't see the curve either. What's that remind you of?
Just a V.
It's a V coming from a...
Is that
linear.
Does it kind of look like a linear?
Is that the
Yes.
number?
Yes.
Is it?
They need to fix
Man, we
it.
not.
I know. Look.
We trying to wear it out.
Okay, and the other day is, oh, we
Right
can't
here.
hear.
Hey, guys.
No, this is why I don't know when voting is, for real.
It's next week,
Okay, but I don't know.
Friday.
You can compare about rattling. No.
Linear.
So right here in purple, I have the equation or the graph y equals x. Right? But here's the thing. Right here, this y value is already 1. And what's the absolute value of 1? 1. Here, I already have a 2. And what's the absolute value of 2? So these points don't change at all. But down here, I have an output of negative 1. And what's the absolute value of negative 1? So 1. So this negative 1 became a 1. Right here I have an output of negative 2. What's the absolute value of negative 2?
2.
And so this negative 2 became a...
Positive.
So see all these negatives?
Yes.
All these negative outputs became what? Positive outputs. This isn't a random V. It took a line and everything that was negative became positive. So all the positives stayed positive. Well, all the negatives became negative. Or became positive. Okay. So, big things I want y'all to note about this. Input of 0 for the middle. Right? An input of 0 for the middle is good. Second, the absolute value function. Where does that absolute value function come from?
The absolute function comes from the function.
Okay, just be quiet.
From the negative function. From the x.
From the linear parent function. We're going to talk more about this later, but we didn't take time to do the linear parent function. Please do that on your own tonight. That'll be the last thing with these parent functions, and we'll start transformations tomorrow.
I got my beat.
Yes, I'm gonna go home,
Somebody push you.
knowing I got work to do.
Be mad at
Yeah, I don't see no problem. You could have still had it. You could have took me, and I could have lied.
But James, did you get all your notes down that you needed for this lesson?
No, you didn't.
They were like, they could have.
yes, I did. Right?
We laughed, chill.
Treat you like some food out there.
Right now, I was doing
Hey,
the
Rihanna,
recording.
is that blinking red, like that is recording still?
It's blinking.
Can you hit the silver button on the back right? Thank you.